Hello everyone and welcome to OpenObservability Talks. I'm Jotans Horvitz, developer advocate at Logs.io, streaming to you live from sunny, warm Tel Aviv, Israel. For those of you new here, OpenObservability Talks is a live stream and a podcast where we discuss about anything open source around DevOps and observability. We usually have a talk or a discussion with experts from the community and follow up in the end of the episode by some news and industry updates. By the way, if you're interested in contributing, do reach out and offer your talk. You can reach out at the website openobservability.io or on Twitter at OpenObserve. You can also reach out to me directly at Horovitz, Horovitz, whichever way that works for you. We're definitely looking forward to having more people from the community involved in our activity and the podcast. And with that, let's move on to today's episode. And today, joining me live from Sydney, Australia, is Albert Teoh. Albert recently joined Logs.io, and I'm very much privileged to be collaborating with him more closely. But also very interesting is 10 years before that, where he was at Uber working with the Jaeger project. I don't know if you know, but the Jaeger project was essentially invented at Uber and then contributed to the open source community under the CNCF, the Cloud Native Computing Foundation. So Albert is surely to share some very interesting experience and insights from this period. Interestingly, Albert also had some work experience working on a radio telescope, including actual observation duties. Quite an unusual experience for a software engineer, so we'll be maybe hearing a bit about that as well. So let's add Albert to the stream. Hey, Albert, good evening. Welcome.
Hey, Jotans. Thanks for having me.
Thank you. And thank you for taking the time in that late evening hour to chat with me here. So let's maybe start with you telling us a bit about what you do and a bit about your background.
Yeah, sure. And firstly, thanks for everyone taking the time to listen to us today. Yeah, it's really an honor I'm happy to be here and really an honor to be here as well. So yeah, recently I joined Logs.io and in fact, it's my 1 month annie Logsary today. Hope I can say that, it's not too cheesy. What I like about Logs.io is that it integrates the best of open source projects like Kibana and Elasticsearch, and probably coming up is M3 and Jaeger. And so all these tools are available in a single page for our customers. And what really excites me the most with Logs.io is that our customers are engineers. And as one myself, I like the idea that there's that visibility of open source. So we can see the commit activity, the quality of the code, how well the project's managed, like the community vibe, and just being able to install these projects on my laptop and tinker around with it. And ironically, I think the speed of innovation and security are probably the two major strengths of open source, especially ones that are used in real-world scenarios. And so currently at Logs.io, I'm part of a team who are currently working hard to get the distributed tracing product, software as a service, out in GA. And on the side, I also do some open source contributions. And yeah, and as you mentioned, prior to Logs.io, I worked in various capacities in web, Windows apps, time series databases, data pipelines, and finally at Uber for 2.5 years. And my last 6 months were spent in the Jaeger team. And I had the privilege to work with one and only Yuri Shkuro, who was the creator of Jaeger, as you mentioned.
Nice, nice. By the way, what was that incident with observation duties on the radio telescope that you were telling me about?
Yeah. So to give you the background, so I worked at CSIRO about 15 years ago. It's a very long time. So CSIRO is a research organization affiliated with the Australian government. And I was embedded within a pulsar research group. And just very quickly, for those unaware, pulsars are basically stars which are greater than 10 times the size of our sun, and they die, so they supernova, and what's remaining is a dense ball of neutrons. And so they emit electromagnetic radiation at a regular pulse. And so one of my responsibilities as part of the team is to take part in observation shifts in pairs at the Parkes Radio Telescope. And we work in pairs because the observation shifts are 24 hours at a time. And then they go over a course of maybe 3 days or more. And so the Parkes Radio Telescope is located in Parkes, which is a small country town 5 hours drive away, northwest of Sydney. And it's not like your conventional telescopes, like with a tube and a lens and mirrors. It's a parabolic dish that is 64 meters in diameter. It's built to receive radio waves coming from space. And so if you ever get a chance to watch the movie called The Dish, it's a great movie, I recommend it. It features the Parkes Radio Telescope and it talks about the history of it, particularly with the significance of the moon landing. Like it was basically to televise the moon landing.
Cool.
Yeah.
Sounds great. Maybe I think probably me and definitely all the listeners out there on the podcast are very interested about your experience from Uber with Jaeger. But before talking about Jaeger and distributed tracing, let's zoom out to observability in general. Like, can you tell us what was the observability stack that you guys used at Uber?
Yeah, so at Uber, for metrics, we used M3, which was a product invented, a metrics platform invented at Uber. And we used M3QL to query those metrics for our Grafana dashboards and for alerting. For logs, we used Elasticsearch and Kibana and some in-house products. And for tracing, of course, we use Jaeger, which was also invented, as you mentioned, at Uber and open source.
Yeah, actually, on the previous episode, we got to talk about M3 and host Matt from the maintainers of M3 and from Uber. So amazing how many incredible open source contributions came out of Uber. Really an impressive company on that respect. But what I find, at least from what I discuss with users and communities, that while logging and metrics is are very well known and established, distributed tracing is far less common, and many don't even know what it's about. So maybe if you can start by giving us a bit about the background of what distributed tracing is all about, and why do we even need it?
Yeah. So for me, distributed tracing is sort of like a method or a means to follow the path of a request as it traverses through like a complex web of services, like a microservices architecture. And like, I guess a good way to explain why it's useful is maybe if we consider an example of like debugging a single program. So what I would do is, firstly, if I discover there's an error, I want to like pose some questions for myself about the software. So like what's the error message? When did the error occur? How many errors happened? Was it caused by my inputs? Did I discover a bug? And so with these questions, then we need some tools to help answer them. And so the first thing that comes to mind is like maybe a debugger, and we can put some breakpoints in if we can reproduce the problem. Do that locally, or we can read the logs from the program. And so if we apply this this method to hundreds of programs in a complex microservices architecture, it's probably infeasible. I would say it would be safe to say, I think, it's not feasible to attach a remote debugger to hundreds of services in production, and nor would it be feasible to sort of run these services like locally on your laptop. just take up too many resources. And so we're left with reading the logs. And I would say that if we had to open up hundreds of logs and sort of scan through them to find our request ID and follow the relevant path across the different services, it just gets really inefficient. And also it's hard to measure latency. So I think this is where distributed tracing really shines. It tells that story of a request as it goes through your system amongst millions of requests that are happening, and pinpointing that particular request, then we can find that a particular service where this error occurs, and then use logs to drill into it. And actually, there was a good blog post that I read this morning that came from Logs.io, actually, from Avi Bolik. And I think he wrote a blog post about causing a high latency problem at Logs.io using Logs.io's own tools. So yeah, managed to fix it in 2 lines of code and 75% reduction. So that's awesome.
Yeah, these cases are always amazing. That the fix itself could be very, very minor, like a configuration error or something like that. But getting down to the root cause to pinpoint the error, that's the challenge there. And there is where I also find that when we use the right tooling, it drastically reduces the time, especially when you're in microservices architecture, as you said. One question that come to mind is, so you at Uber decided to go ahead and invent essentially Jaeger out of nowhere. Can you share why you find it necessary to create a new project, a new tool, and not use existing solutions?
Yeah, so I guess firstly, distributed tracing is pretty important at Uber because you can imagine with the company that has 3,000 plus services, it's really important to just find that needle in the haystack. And so secondly, the reason why Jaeger was invented at Uber, firstly, I guess admittedly it's before my time. I think Yuri wrote a really excellent blog post about the evolution of Jaeger at Uber. But basically, Zipkin was used to start with, and that was the most well-known tracing product at the time. And I believe the UI and the query engine were used. And so Uber wrote some custom components to write Zipkin compatible spans into a backing store. And so, but there was some shortcomings to it. I think from memory, it was instrumentation, the transport, and data model were the main points, the main shortcomings. So instrumentation-wise, Zipkin only supported Java and Scala. And so at Uber, we used Go, Python, Node.js, as well as Java. On the transport side, Scribe was used to send the spans over. But at Uber, we used T-Channel. And in terms of the data model, there was a requirement at Uber to be able to write structured logging into a span. So you can see in Jaeger, if you ever see Jaeger and you open up a span, you can see those logs with a key value pair. And Zipkin didn't support that at the time. So I think they're the reasons why Jaeger was invented.
Yeah, makes sense. And I think one of the things that many people struggle with is the instrumentation. And obviously, especially in microservices architecture, different microservices can potentially use different languages and different frameworks. And the challenge is always in adopting, distributed tracing is to be able to plug in to your programming language and to your frameworks and do easy instrumentation, maybe even auto instrumentation when possible. So definitely. By the way, you mentioned some terms about spans and some others. Would you like to maybe share with the audience just to make sure that everyone is aligned on the terms?
Yeah, I'm glad you called me out on that. So a span is essentially a unit of work, and it consists of a start time, a duration, like a service name, operation, and some other like metadata in the form of tags. And also, I mentioned earlier the concept of logs inside a span. And a trace is that collection of spans which are causally related. So usually the relationships are parent-child, and so the trace represents the entire story of that particular request.
Yeah, that's good. Essentially, just structured logs that are for the format that is used in the tracing. Yeah, that's definitely good. And so at Uber, when you came up with the distributed tracing, what were the use cases that you specifically at Uber? What were the use cases for that?
Yeah, so I can think of three main use cases. Sorry, not main use case, but three use cases that that I was exposed to while in the team. The first one is probably the most common use case that we often think about, which is identifying errors in latency and drilling down into those. And that was particularly important for something like black box monitoring. The other two are a bit more nuanced. First one is service refactoring, and the second one is more of a business use case relating to cost attribution and capacity planning. That one wasn't really realized while I was there. It was more of a proposition.
Yeah, so everyone is talking about, in the context of obviously finding performance issues, like the example blog post that you mentioned. But actually, you said the one that was about service refactoring. Can you share a bit more about that one?
Yeah, so probably the best way to explain it is maybe through an example. So imagine we had 10 services all related to payments. And so we want to consolidate that into maybe a gateway API. So these services would exist underneath this umbrella. And there are a couple of reasons for that. I think one main benefit of it is it simplifies the architecture so that services that rely on payments, they just need to know this one API rather than needing to know there's this service A and service B and service C, which one do I call? And the other advantage is that you can chop and change services underneath that abstraction layer under that gateway. So you can decommission services, add new services, as long as that API contract is satisfied. And so where Jaeger comes in there is there's a feature in Jaeger called system architecture or dependency graphs. And so with that, you can sort of instantly see who are my upstream callers. They're the ones I need to communicate with to say, hey, can you redirect your calls over to the gateway, not to service A, B, C. And then from there, project managers can sort of monitor the progress of that migration as well.
Yeah, I think one of the interesting things about when I started working with Jaeger is that suddenly I started seeing more like a different persona in the interactions, which was the architect. So, with metrics and with logging, it's one profile. But then for Jaeger, you see, in addition, higher level people, usually architects or someone system engineer that needs the broader view, and they come to Jaeger and distributed tracing from a different angle of actually getting visibility into what's the system is about. Because traditional schemas of showing the interaction diagrams and the flow diagrams and others are impossible to maintain when you talk about dynamic microservices architecture and stuff like that. And here essentially you have it auto-instrumented and tells you the relationship between the different services. So that's an amazing benefit that Jaeger brings, and the dependency graph and the system view that is definitely beneficial, like the example that you gave on finding the callers in order to update them based on your changes of the API.
Yeah, and a shameless plug. Our team is actually working on this feature right now. The team's working harder, and it should come out with the Jaeger product when it comes to GA. And also, if anyone's interested about the example I mentioned, there's an Uber engineering blog post on domain-oriented service architectures. So.
Cool, thanks. Send me the links afterwards. I'll definitely post it together with the podcast after we finish.
Yeah, sure.
So. Another thing is like, okay, so you had you had Jaeger and you had the understanding that the distributed tracing is needed. But what I find, again, talking to people in the community, is that introducing it when you have already a system in place, and then you try and introduce distributed tracing is not always a a smooth process. And I mentioned before issues about instrumentation and others, but I'm actually interested to hear what your challenges, the challenges that you encountered at Uber for introducing and adopting Jaeger within Uber.
Yeah. So there are I think there are two challenges that come to mind right now. And the first one was increasing adoption at Uber. And it's important because if there's a service that's not correctly instrumented or has broken context, it can potentially lead to large blind spots within our trace. And so basically what happens is if the context is broken or not, if that service isn't instrumented, we end up having a service that I guess that service ending that span chain, I guess, and it creates a new trace in the end. So it gets very confusing, and and also it nullifies the usefulness of distributed tracing, because you want to see the entire trace rather than half of it. I think it was also a challenge because there was little direct benefit for service owners to fix their instrumentation. And sometimes it was quite a large effort to do so. And so that meant that they lacked motivation to fix it. And the second challenge on that was it was just a large matrix of languages and frameworks and versions at Uber. So we had languages like Python, Node.js, and Go and Java. And then each of them had their own frameworks for dependency injection and whatnot. And then they had each language had its own version or had their own version of frameworks. So yeah, it became a bit of a mess. So the other challenge is the fact that finding a trace was a hit and miss affair for developers. So developers would often see their trace ID in logs. And so they go into Jaeger and then copy paste their trace ID in the search. And they end up not finding it, and then they'll come to us and say, hey, I can't find this trace, what's going on? And unfortunately, because Uber produces so much span data that we have to sample. So we have to sample, I think the rates that we use is 0.1%. And so what happens is, I guess I could explain this a bit later, but we use head-based sampling, and we sort of pick and choose a small percentage of those spans before it even propagates through the entire chain, just to reduce the amount of network traffic and spans hitting the collector.
Yeah, I think these are definitely common issues. But if you mentioned the sampling, actually, this is something that I know that many, including myself, there's also the debate on the sampling rate and the sampling strategy and the benefits and pros and cons. Maybe you can give us sort of your take on the sampling, the different the different options, the different trade-offs.
Yeah. So I think so as I mentioned earlier, the reason why we sample is because we want to reduce the amount of data that's coming into our backends. And so if you imagine, we had a conservative example of, say, a gateway service that's 1,000 QPS, so queries per second, and it has 10 spans, and assuming that the trace finishes in 1 second, and we have a max payload of 64 kilobytes, which is the UDP payload, maximum UDP payload. And so that adds up to like 640 megabytes per second, which is quite a lot for a conservative example like this. And so that's where sampling becomes very important. In terms of strategies, there are two well-known strategies with sampling and distributed tracing. There's head-based and there's tail-based. So head-based is where that decision is made upfront, and that's why it's also called, it's also known as upfront sampling. And so basically that first span, which is also called the root span of a trace, that service is what determines if that trace should be sampled or not. And so there's various strategies within the head-based sampling. There's like probabilistic and const. And also you can have the sampling controlled by the collector as well, by the backend. So there's tail-based sampling, which is where you accumulate those spans in the backend, and then decide at a certain point in time when that trace is considered complete. And once it's complete, then you can decide, should I sample this or not? Like, is it interesting or is it not interesting? If it is interesting, then we keep it and persist it in our backend. The advantages of head-based sampling is that it's very simple to implement. It's efficient. You can distribute the compute of that sampling decision out to the to the root spans or root services. But the problem, as we mentioned earlier, is that you end up missing a lot of potentially interesting traces. And so on the other hand, in tail-based sampling, it's more complex, it's more resource intensive because you need much more CPU, much more memory. But on the advantage is that the advantage of that is you optimize your storage utilities because you only store the most interesting traces. You don't store like duplicate traces and like very similar traces or non-erroneous ones. And it also unlocks like a whole bunch of use cases like security alerting, like aggregation, like metrics aggregation. So yeah, that's sort of the trade-offs that I can think of.
Nice. So in your case, in your experience, what was the strategy, if you can share, and why, like in your specific case, how did you come about to your decision and the best path for you?
In terms of sampling?
Yes.
Yeah, so at least at Uber, head-based sampling was the only available sampling strategy. Tail-based was in the works, excuse me. And the sampling strategy within head-based was to defer to the collector, to the backend. And the reason for that is just it was so important to have the centralized place where we make these sampling decisions to make sure that the backend doesn't get overwhelmed with the fire hose of data of spans coming in. If we left it to the services, then they may not understand that further down there may be a large fan out causing a massive increase in spans.
Also, it's an overload. All these making all these decisions, it may slow down the actual application, the actual services themselves, I assume, which is also a consideration architecturally.
Yeah, that's a good point. Yes, that's right. There's a bit more work. At the same time, though, spans are submitted out of band. It's only the context that's transmitted in band, and the sampling decisions made up front only once at the top. So it shouldn't be too much additional workload.
Gotcha. By the way, I wanted to tell our listeners that on the live stream that you're more than welcome to submit also your questions, whether on YouTube Live or via Twitch, and we'll be happy to. I have lots of questions. I can keep Albert occupied for many hours. Trust me. But if you have good questions from the audience, feel free to type them in, and we'll also challenge Albert with some out of band questions as well. You mentioned also when you mentioned the challenges, Albert, you mentioned about the context, the aspect of context. Maybe I think it's something that is not well known in the amongst the community, the aspect of context propagation and the problems of broken context. Maybe if you can explain a bit about that.
Yeah. So context propagation is it's like the vehicle that's used to transport the trace metadata throughout, throughout the call graph of a request. You can think of it. I guess you can think of an analogy where you have a tree, and so without context propagation, you would just see the leaves. So context propagation allows it provides the relationships between spans to create that tree. So it's like the branches that you see in the tree. So you're probably wondering, like, probably one question that comes to mind is, like, why can't we extend the API of each service to pass in this context. So I guess to give a bit of background, so context propagation is something that's serialized and deserialized from the message headers, and so it's transparent to the service. And so then the question arises, like as I go back again, the question arises: can we just extend the API to include this context object, I guess, that contains the tracing metadata? And so if we did that, for example, we have a database abstraction service, which is 10 calls deep, so 10 services deep. We have a chain of 10 services. And if we want to see a span from our database service within a trace, we need to coordinate with each of those 10 services and say, like, hey, service A, can you please add this API, add this to your API, this context attribute. Hey, service B, can you do the same thing all the way to service K? And you need to literally have each of those services enable this additional parameter for you to even just see your span in that trace. And so context propagation allows you to send this, to propagate this tracing metadata without changing APIs. But that also assumes that within your service, the context is correctly propagated from ingress to egress.
Got you. And the aspects of the broken context, you mentioned that as part of the challenges and how you handle that. Can you tell us a bit about how you handle that at Uber to actually put it in practice, to make it an active distributed tracing in your system?
Yeah, so it wasn't easy and still isn't easy. So there were sort of 3 initiatives, like company-wide initiatives, to help address I guess, to increase adoption and to fix context propagation. The first is to consolidate the languages that are used at Uber. So I mentioned earlier that there was Node.js, Python, Go, and Java. So we consolidated those to 2 languages, which is Go and Java, for backend services. The second is that Uber encouraged everyone to adopt the latest frameworks to enable auto instrumentation. So that included Uber FX for Go, and JFX for Java services. And the third one is to migrate to monorepo. It was a mandate, a company-wide mandate for services to adopt monorepo. And it came with the advantages of standardizing the frameworks that services used, and standardizing and having basically a single version of frameworks. And so if we ever needed to upgrade, like to upgrade or to downgrade versions of our, like, say, Jaeger client, we could do that theoretically in a one-line code change. Yeah, so we had a Go monorepo and a Java monorepo.
Nice. So that essentially made it an integral part of any new service that was written, because they were all based on the same framework. They were initiated by the same monorepo.
Yeah, that's right. That's right. And so probably the next thing that we needed to do was, I guess, how do we identify? The next question is probably how we identify like broken instrumentation. That problematic instrumentation in services. And so the first thing that we need to do is understand what patterns, because at the time we didn't really have a good understanding of how to fix this problem and how to identify the problem in the first place. So we had to manually go through some example traces and certain patterns. There were certain telltale signs of broken instrumentation. So for example, if you have a leaf span that was of span kind client, it sort of indicates that that span was making an outbound call and we can't see that child span. So that's sort of a sign that there's broken instrumentation there. And so that was an input into the automated approach, which was a hybrid of static and dynamic code analysis. Yeah, so the we found out that with just a static approach, which is basically going through the code and looking for functions that aren't propagating the context object, that took up to 5 hours just to analyze a single service. And so, of course, it's not feasible, especially if you want to do like include this in a CI/CD pipeline. It's just everyone will be angry. People will leave the company. So we needed to adopt. We need to use something. So this was done by researchers, so people far smarter than myself. So I'm trying to explain it the best I can. But there was a dynamic approach as well, where they sort of look at the calls made in production, and so understand the call paths within code, and that sort of narrowed down the search space for the static analyzer to do its thing. So that's how we sort of identified broken instrumentation.
Nice. That sounds very interesting. So you had the services. By the way, how many microservices are we talking about? Just to understand the order of magnitude.
Between 3,000 and 4,000. I don't know exactly how much, but yeah, between those two numbers.
That's enough to get the sense of things. Did you also have sort of more legacy parts of your system? I think you mentioned something before, because I feel, at least from my interaction with people, that we all think about distributed tracing in the context of new modern microservices architectures, and obviously the benefit there is clear, but many are still now transitioning to microservices. They still have some pieces that are more legacy code, but still you need to address those. And as you said, you can't leave black holes. You need to get the full mapping end to end of the sequence. So maybe if you can share a bit about addressing the legacy part of the system.
Yeah. So most of the legacy services were the Node.js and Python services. So for those, there was basically a mandate for service owners to migrate over to Go or Java. There were also legacy services within Go and Java, and so that's where we encourage them to sort of migrate over to the latest frameworks. So, for example, FX, UberFX was something is an open source dependency injection framework invented at Uber. And so the idea for that is it would auto instrument your service to handle, it had some middleware to handle, to extract inbound requests, extract the span data, and then, produce, emit the span from the inbound request. And then on the outbound, it would inject, on the outbound, then it would emit another span, so that you can have your client side and your server side spans for each service at the very least. So that's sort of the approach that we took for handling legacy services. The other, I guess the trickier example where we have broken context in legacy software and legacy services was when services would create a new context object. And the reason for doing that sometimes was a bit hacky, but they wanted to extend the timeout period of a request because some requests were taking too long and would just time out. But that led to losing some span data if they didn't copy the original span context over. So definitely a good practice is pass the context on without touching it. But if you can't, use the context with span function that's available in the Open Tracing API to copy that span over into a new context that you've created. And so we would, to start with, we would manually provide these diffs to service owners for them to use. But of course, with 3,000 to 4,000 services, that's not really scalable. So there was a researcher who was working on an automated way of doing this, but as you can imagine, it's not an easy task, I think. So,
to say the least. Yeah. By the way, one of our listeners just sent us a link, saved you from sharing the link with us. So at the bottom, github.com/uber-go/fx, the link for the FX. So definitely, thanks a lot for sharing the link there. And I think actually we have another question from the audience on sampling. So if you can talk a little about the sampling methods beyond when, namely head versus tail, according to which you make the decision, that if you can expand on that.
Yeah, so I'm not overly familiar with this, but I know that Yuri was working on adaptive sampling. Yeah, unfortunately, I can't comment too much about it reliably, but the idea is that there are some low QPS services which may not. They rely on that chance call where a branch in the code ends up calling their service. And in order to be, and that only then can that be available for emitting a span. If the sampling decision happens so that like in the head-based sampling that it's disabled, there's no sampling, then most likely the service won't even get a chance to be called. But I think adaptive sampling is designed to handle that situation. Exactly how, I don't know why. I don't know how. But yeah, I think there's probably a blog post out there that Yuri's written about that elaborates more about adaptive sampling.
I think that what the industry has been struggling with, even starting the days of the Doppler project by Google, was the topic of sampling and whether using just arbitrary sampling, taking 1% or 0.1%, but then it's very arbitrary across all the various types of flows in your system, or whether to do something more intelligent where you prioritize the critical paths of your system, and of course take higher samples there rather than something sidetracks that are much less critical, and the issues there are much less impactful, and there you can take lower sampling to get maybe a better balance between the cost effectiveness of not overflowing your storage, and still having good visibility into what happened in your system at least in the critical path. So I think this is something that the adaptive sampling is trying to tackle, and yeah, you gave us a very good overview on that. You mentioned before when you talked about handling the sort of the legacy and how you standardize it, you mentioned like open tracing as an example. Could you what's your view on the open standards around tracing?
So I would say I would definitely encourage the use of the open tracing API. If for anything, it's for one's own benefit. It just means that you won't be locked into a vendor. It means that you can change your tracer from one vendor to another quite easily, and still maintain that your core business logic. You don't have to change that code. So basically, it's just changing that initialization of your tracer. I think the other advantage is that you have a consistent API experience between languages. So if you have multiple languages used for your service implementations, you have that consistent experience, I guess. Yeah, and one thing to mention also is that there's an effort called OpenTelemetry, which is an initiative to sort of merge open tracing and open sensors together. I'm still learning about it, to be honest, so I don't know too much. I can't comment too much about it, but that's all I know.
Yeah, actually, OpenTelemetry, I'm also I'm participating in some of the SIGs, some of the groups there, interest groups there, and some of my colleagues as well. And it's definitely seems to be the leading effort for standardization. Also, with all the sprawl of standards, you mentioned the open census and open tracing, and there's also open metrics and others, a way to converge all of them under one standard that has an overall view across observability, different pillars of observability, also under one roof. The CNCF is definitely something that looks promising, although again we're waiting still for the GA, hopefully for at the end of this year at least, on tracing and on metrics. But yeah, we're all following very attentively. I think we may have time for, by the way, again, to the our audience, the listeners, do feel free to drop in your questions on YouTube Live or on via Twitch, and we'll definitely be happy to add some of your questions to Albert as well, beyond my silly questions. But one thing that you mentioned before on the use cases that you had at Uber for distributed tracing was something that is far less common, and that is the aspect of, you mentioned the sort of more business-like types of aspects of cost attribution and capacity planning. That sounds fascinating to me, like the BizOps side of things. Can you tell us a bit how you viewed that part of using distributed tracing?
Yeah. So the motivation for that is to understand. So in terms of cost attribution, the motivation for that is to understand how much a product line or a business line is costing for that particular product. So because you have services which are common to multiple product lines. An example of that would be maybe the early example where you have a database, like a data store abstraction. So multiple products will be using that database, that data store. And of course, it costs money to run that service. We need people, we need compute. And so the idea here is that we could use Jaeger to understand the percentage of time that a product line would spend on that particular service. So to give a simple example, you have a product called Eats and another product called Rides, and you could have that common database service. And so maybe Eats would use 30% of the time on the matchup service, and Rides would use 70%, the remaining 70%. And so from there, then you can say, okay, if the database service costs $1,000 a day, then we would attribute $300 of that to the Eats service, sorry, and $700 to the Ride service. And then from there, you can compute what the profitability of those product lines are. In terms of capacity planning, quite similarly, you understand the relative percentages of time spent on that common service. And so if you anticipate that the Eats service is going to grow a certain percentage, and similarly with Rides, then you can sort of increase the relative plan for that additional purchasing of storage or compute power for the following year based on the anticipated growth of those product lines. So that's the general idea. Yeah. Sorry?
So essentially, you actually managed to sort of harness and connect the sort of the finance side of the operations into using the inputs from the outputs of the distributed tracing to help them calculate the again, both for capacity planning and for actual cost attribution.
Yeah, precisely, exactly. It's basically the key is to understand how much time is spent on each by each of the product lines on a particular shared service.
Amazing. That actually is the first time that I hear that use case for distributed tracing. That sounds really fascinating and lots of potential there. I think we're about to run out of time, so I would like to thank you very much, Albert, for taking the time here and sharing all this knowledge with us. I'm looking to see if there's any further questions from the audience to Albert before we wrap up this part and move on to the news. So last chance, guys. Not every day we get to chat with an expert like Albert. Well, just a thank you, but still. Great. So Albert, appreciation not just from me, from everyone. Thanks a lot for joining us, taking the time off your late evening time to chat with us, and I'll definitely be following up with you afterwards. Thank you, Albert.
No worries. Thank you.
Well, and now it's time for the breaking news. Now, let me bring it up. The first thing that I wanted to share with you is about Cortex and Thanos, two open source projects that just moved into incubation in the CNCF, the Cloud Native Computing Foundation. Now, I don't know if you know about what Cortex and Thanos are about, but you definitely heard about Prometheus. Prometheus in the observability space is currently essentially the de facto standard for metrics, for system monitoring. And although it's very popular and in wide adoption, it does have its own share of issues with regards to high availability, horizontal scalability, having sort of the unlimited retention need that keeps on pushing upwards with systems, the multi-tenancy and so forth. And there are a few open source projects out there that aim to augment Prometheus with to overcome these issues and offer a long-term storage for Prometheus as a backend. So both Cortex and Thanos aim at that purpose. And I think, first of all, the fact that they were moved, they were accepted into incubation are a good testament for the fact that actually Prometheus is indeed the standard and the go-to in terms of metrics. And also, it's a very good move in terms of the community move around the metrics, because again, Prometheus has its limitations, but having additional open source projects augmenting and also working in collaboration is very crucial. And both Cortex and Thanos, by the way, if you look at their contributors and their maintainers, you'll see names from Prometheus. So there's lots of synergy, lots of cross-pollination, which is definitely beneficial for the industry. And I think in that context, maybe I should mention also another open source that is showing very promising directions as long-term storage for Prometheus, which is M3DB. I mentioned that earlier in this talk. So we had on the last episode, we actually hosted one of the maintainers of the M3DB. So definitely worth checking out that episode to get more information about that. Now, another thing that I wanted to share with you on today's news is also from the CNCF, is the end user technology radar that was just published September 11th, so 2 weeks ago or less. And that one was squarely focused on observability. So right down our alley, and I think it has some very interesting insights, although we need to get more end users participating, and we can also improve the research, and we're working within the CNCF, within the SIG observability group and others to improve, but definitely a good pass on that and very interesting insights. I invite you to read that. Just a few things that I would mention. For example, on the radar, we see all the open source projects that we discuss normally here on OpenObservability Talks, like the Elk Stack, Prometheus, Grafana. You see here Jaeger, you see here OpenTelemetry, Thanos. So all of these definitely shine on the radar. But more importantly are the themes that arise from that report. Firstly, as I mentioned, that the most commonly adopted tools are open source, like the ones that I named, open source tools or open source standards. So it currently compiles both of them together in one in one research. Maybe later researches we can divide the two. Another interesting point is that there's no consolidation in the observability space. This is definitely something that I feel that comes up in every conversation that I have with users, with clients, with partners, and everyone brings that up, and the research just puts numbers. Half of the companies are using 5 or more tools. A third of them had experience with 10 or more tools. So a lot of tool sprawl in the observability space. That's a headache for all of us, and begs the need for consolidation and also for standardization. And maybe the last point that I would mention is the Prometheus. We mentioned Prometheus before in the context of Thanos and Cortex. So Prometheus comes very tightly together with Grafana, very frequently used together. Again, a very common pattern. So reach out and check out the End User Technology Radar by CNCF, and a good webinar also on that. We have time for maybe the last piece. So I don't know if you've heard, but Kubernetes 1.19 was just released. And on the observability side, one very encouraging thing that I was looking for came out, which is standardizing on the system logging. So I don't know if you've ever tried gaining observability into Kubernetes itself, meaning the actual control plane of Kubernetes. If you have, you probably saw that different services use different standards, different formats for their log strings, and it was pretty hectic to do the ad hoc parsing for each one individually. So on this version, finally, we see the consolidation. We see structured logging, both on the strings themselves and even now as a JSON output. So the Klog now can provide and support these. I want to mention that it is on alpha. So if you, before you run and go adopt that, do check and make sure that you have the functionality that you need on the structured format as well. But definitely very interesting. I updated my blog post about, if I may shamelessly promote my post about the practical guide to Kubernetes logging. So I updated it with this update and also provided some links. So feel free to look for a practical guide to Kubernetes logging on the Logs.io blog and check it out and follow the link. I think there's no time for more news for that one. So with that, I would like to thank you everyone for tuning in and listening. Of course, I would like to thank Albert for joining us and for sharing his very, very important insights about distributed tracing, about observability, and about his experience at Uber. This episode, together with the last episodes, are all going to be available for listening on your favorite podcast or on YouTube. So feel free to look at the YouTube channel or follow us. The next episodes are going to be, we broadcast every month at the last Thursday of the month. So feel free to join the stream on Twitch or on YouTube Live, Twitch at Observability. And all the details, you can find them on the website, OpenObservability.io. And also follow us on Twitter, OpenObserve, or feel free to reach out to me personally at Horovitz, Horovits. And again, if you are interested in participating, in having a talk, if you have something interesting to share with the community, do reach out to us in any of these means, Twitter or the website, submit a talk or any other means. We would love to have more of the community involved in this podcast. So I was Jotan Horovitz. Thank you for listening and looking forward to having you again on our next episode next month.